Good day, chemist in Japan de gozaimasu. Well, today is Omisoka, the last day of the year, and as part of a New Year's tradition, I am doing Soji. Soji is cleaning, and O is big, so this is a big cleaning. It's what families might normally do at the end of the year, clean up the entire house, you know, pull out the tatami and give it a good cleaning and everything. Soji. Well, in a similar fashion, I've been doing that kind of today, although I have to admit it was not simply because of Soji that I'm doing this, it was because, well, it needed to be done. So I've taken my hood all apart, taken everything out of it and cleaned stuff. So you've seen it before, but this is my work area. We call them hoods. Vent hoods. They're about inside this glass is where all the work takes place, and as you can hear it, the blowers, it's actually sucking air out, and there's a sensor up there to tell you, or to tell it when someone's standing in front of it, and then it knows how far the doors are open or if the sash is lifted like that. So it knows. So anyway, so my hood is all taken apart right now. So I thought I'd take a minute and just show you what's in here and maybe talk about a little bit why it's in there. The most important thing that I have in here, it normally hangs up there, but this is my Schlenk manifold. And what it is it's two glass tubes. This here and that, two glass tubes, and they have hose connectors on the end of them. That one has two of them on both ends, and it has these valves, and these valves, as you can see, connect to the two manifolds. And then we have this stopcock to open and close the valves. This was developed by a guy named Schlenk, and so we call it a Schlenk manifold in his honor, because what it allows us to do is to work with air-sensitive chemicals without ruining them. So in one side of the manifold there is inert gas such as argon or nitrogen. I use nitrogen here. In other hoods we use argon. I prefer argon, but this is what I have to work with. The other one is for vacuum, and the vacuum pump connects there. And so we can easily switch back and forth between vacuum and inert gas and work with our compounds, and we can transfer things from different flasks with using the Schlenk line. It's a very amazing piece of equipment, and that is what allows me to do the chemistry that I do, because everything that I work with is either air sensitive or water sensitive. Air as in oxygen. Oxygen sensitive or water sensitive. And so it took me a long time to get used to using those techniques, but I've gotten better at it. The vacuum hose is right here. That goes down below to my vacuum pump, which is down there. And that pulls the vacuum. A very good vacuum, actually. Normally, what is right here in this clamp is my vacuum trap, which is in two pieces right now. So that's what it looks like. So the vacuum pulls here, and it pulls on this tube, and then this is connected to the Schlenk line. And it pulls a vacuum, and this, I'm just going to use this part, this sits down inside that dewar that's supported, and that dewar is filled with liquid nitrogen, so that any gases that try to enter the vacuum pump are stopped by the liquid nitrogen. For the inert gas, we have to relieve the pressure, but we have to relieve the pressure but not let other air in. So you've seen it before. This is my oil bubbler. That's very tall. It goes almost to the top of the hood, and the right-hand side connection is where the tube connects to right here on my Schlenk line, and the gas flows through it. So that's basically it. The gas actually comes in here, and it goes to here, and I have it split. One side goes to my Schlenk line, and the other side goes to a standalone valve right there. So this is where they both are. That's how I control the gas flow. The yellow one did go to this standalone bubbler here that I had for a certain reason, but that's gonna go away probably. And my hot plate that I use right now. So that's what's in my hood. That's what allows me to do all the things that I do. I'll put it together and show you what it looks like when it's all assembled. So here's my Schlink manifold fully installed again. If you notice, it's got 4 black handles on the top and 3 on the bottom. That's because unfortunately right here there was an accident before my time, and we never replaced this part of the valve. So that one has vacuum only. So the vacuum hose comes up from the bottom from the vacuum, goes up and around, goes into the vacuum trap, which is there, and the black hose puts vacuum onto that top one. So I have 4 vacuum positions. This one I mainly just use to release the vacuum, and I have 3 fully functioning valves for Schlink operations. So since I just put it all back together, I have to check the vacuum, make sure it pulls down. Basically I'm going to do this by an audio test, just by listening to the vacuum pump. And then later I'll put a manometer on it and actually check it. So, turning the switch. And there we go, got a vacuum. When the vacuum pump stops making noise, that's when you know it's pulling a vacuum. That's a Welch Dual Seal vacuum pump. It's very nice, I like it. So this is the main valve here for nitrogen. It says N2 for nitrogen. And we'll turn it on. I turn it on all the way, and you can see the gauge has come up. It should show 10 pounds. Yeah, 10 psi. I use that as the main valve, and I use this one right here to control the actual flow. So when I turn the valve, hopefully if all goes well, nitrogen will start bubbling through. And there it goes. I normally keep it at a decent rate. Okay. Too fast. When I'm running a reaction, that's usually about the rate that I have it bubbling. And they go up. I've shown you this before. And eventually, a bubble show will start there. Some sort. It'll start doing funny things. But anyway, so there it is, all back together again. Everything I need to do, well, at least gas-wise, for chemical reactions. Hopefully I'll be able to show you something more interesting coming up, but it's hard to do. But anyway, thanks for watching.